Hello again, guys. I'm Rafa from Rodin 4D, and as you can see, we was during approximately 2 weeks without webinars because, like you can imagine, we was doing a lot of trainings to many of you that demand more trainings, and also many new customers. In many cases, many customers they decide to move from other systems to Rodin. So yes, it's every time it's really nice when you can train and share your knowledge with other colleagues. But today we decide to restart our webinars. So I was thinking which one would be great, and we decide to start with templates. As you know, in our software you have many library forms, but in many cases the people prefer to create their own templates because they prefer to use their positive shapes. So everything is possible. There is people that they can start with the original shapes that you have in your library now, but in other cases people prefer to go to the workshop, select a good positive, add some plaster to prepare and smooth and clean everything, and after a scan import in Neo and save like library forms. Okay, so when we speak about library forms or templates, there is two ways to use it. One would be to modify according to a measurement protocol. So, as you know, in our library forms, it's mandatory to have levels. So in these cases, you need to identify same levels on your patient and take measurements: circumference, AP, ML, and the height, the distance between the levels. As you can imagine, it's mandatory to use a good measurement tools. The other possibility would be to merge your library form with a 3D scan. So when you decide to create your new library form, the first important thing is to select the good positive shape. This is the most important. And after this, you import, and you can you have the possibility to save in the historical window different steps to rectify this shape. At the same time, you can save in your template measurement to control specific circumference, ML, diagonal angles, and something like this. You can save as well the trim lines, because as you can imagine, of course, every time you will rectify the positive shape in Neo, for me, I have no doubts, no? It's faster to rectify in Neo than in other softwares. And when everything is okay, you can edit the trim lines you have in your template and export to STL to start to give thickness, apply texture or something like this to send to the 3D printing. So today you will see, I will show you how you can create an AK, BK, TLSO, AFO, KFO, and HKFO. With 6 samples, you can understand everything very good, and after you have the possibility to create more library forms. For example, it's important when I spoke about the first step, no, to select the good original shape. This is important also, for example, when we speak about the TLSO. If you want to make a normal brace, probably it's not really important, no? But if you want to rectify Chenot brace or Rico brace or the similar like this, is important to control this original shape you use in your template. Because imagine that you create your TLSO starting with a shape with a thin morphology, and after you want to readjust to a new scan for a fat girl, as you can imagine, you will have no problems, but you will spend more time because the morphology are completely different. So in this case, I suggest you to create one template with a thin shape and a new one with a fat shape. So let's start because I want to explain many things, okay? So let's start with the AK. I will go to the patient folder, right button, new patient, AK template, right button, new form rescan, because don't forget that this is in case you scan your positive shapes and after we want to use the STL. Okay, I will look on my desktop. Where is this one? Okay, and now we need to align. In this case, let me check. I think that no, it's more or less okay. We don't need to modify nothing. I want to fill the hole we have on the distal part. It's important by default check in the advanced mode if you have activated this part, closing from bottom, okay? So now click on next. The system will convert the STL in Routine 4D form, and now everything is okay. So click on finish and open. Okay, the first thing is to define the level 0. Normally in AK we need to put the level 0 at the Pyrenees, but here you can see that in this case is the trim line of the back part is smaller, and we need to start with the first real circumference around the shape. This part is not true. So in this case, for example, if imagine that this is the Pyrenees and we have 53 according the 0, so I want to move for example, I don't know, 20 millimeters, so I will leave until 33 here. I want to save the level 0, and I can rename like 20 millimeters below Pyrenees. And after this is important to control this when you have the patient. Okay. Now I want to show you how in one socket like this is mandatory to control many measurements in the proximal part. There is people, they like to use 3, 4, 5, 6, 10, 15, and this is up to you. And the goal now is to save in our template. So if you go to the measurements, you have these functionalities. I want to explain to you, for example, how to use the 3D line, the angle and the plane. For example, the first one, I want to rename like angle Ramos. Okay, and the system gives you 3 dots. The second one I will put in the back part. This one I want to put anterior, and this one I want to leave approximately here. Now I need to put here, okay, and after this one I want to move and leave approximately I think something like this. This is the line of progression. Now it's important to project on the distal plane. On the distal plane, probably this one, let me check, because if this is the top view, probably this one I think is more or less okay. Perfect. The next one, I want to use the 3D line. For example, in this case I want to control the ML osseous. So before to click in this icon, is better to click where you want to see the new dots. So I click here, 3D line, and I want to rename like ML osseous. Okay, and now I want to put this one here, and the other one I want to move. Okay, let me see from the front view. I think it's more or less like this. Okay, and now I want to be sure that is in the yes, I think it's okay. Of course, like you can imagine, when you prepare your template and you put the dots here and here, is mandatory when you use the tool or the caliper to take these measurements to put exactly in the same position where you are saving your dots. If not, of course, you will have problems. Now I want to show you, for example, how you can use the plane. In this case, I want to click here. In this case, I want to rename like AP medial. Okay, and I will put the dot approximately here. The plane now it's on the right. I need to leave at the posterior part. Okay, the system, the plane is touching the part more prominent, but with the offset I want to move till half at the back part of the ischio. I think something like this. You decide, you can play with the offset. And after the system give you the distance from the plane to the red dot. Okay, so you can see here. Okay, and you can use more tools to control diagonals, MLs, the AP, everything. No, you can control also the distance from the ASIS to the adductor, and many things. Now, for example, I want to use the upper limit to design the trim line, in case you want to import in our Cube software to send to the 3D printing. It's important to prepare your template thinking in all the possibilities. Okay, now I want to add more dots, something like this. Okay, and this one, and this one. Probably I need to add a new one here, and I think it's okay. I want to deactivate the symmetrical, and now I want to start to put in the good place. Okay. This one here, this one here, leave approximately, I think it's more or less okay. This one here. Now the back part. Okay. Something like this, I think should be okay. Okay, so now you know that with functionality you have the possibility to control your socket. Okay, so and after in the tool panel, of course, you can add different tools and functionalities to start to use it. For example, the first one is the prosthetic measurements. It's mandatory to use it, so I want to prepare in the historical window, and you can add a list of many lines. So now everything, imagine that everything is okay. You need to save like a library form. In my custom bar I have already here, but if you haven't here, you must go to File, Save, Save As, and Export as RxP. And after this, in your library, you rename like template AK webinar. And that's all. Now I want to create a new BK template. So patient folder, click on it, right button, BK template. Okay, right button. In this case is the same, like imagine that you have a very good shape. So here, uniform rescan BK. I will look on my desktop and I have this one here. Okay, probably we need to bend a little bit. Let me check if everything is okay. I think so. For example, here, no, I think we need to leave like this, much better. Okay, no, I think to turn like, okay, perfect. Okay, so after this, click on next. It's important to check the top view. I like to leave open and the bottom part completely closed. Finish. Okay, and now in this case for me it's much better to leave the level 0 in the midpoint of patellar tendon. So now here, if you have not here this functionality, go to landmarks and use this one to add the level 0. You can rename and you can put if you want something or not. It's the same, but we can put, yes, midpoint patellar point tendon. Okay. Okay, to show you other things and possibilities, imagine that you want to save, you want to create this template to rectify a PDS. You can start to use different tools to apply pressure, expansion, or something like this. But also you can go to other shapes you have in your computer to select and import here. This is the thing I want to do now. Here in my custom bar, you have the import tools. In a real case, I don't know, let me check. I don't know if you have in the, yes, in the advanced tools you have here, import tools. So I want to click here, and after in my, for example, I want to use all the tools that I share with you in in the BK template that I use in the webinar we organized a few weeks ago. This one, okay? So now all the tools I want to activate. In this case I have no measurements, and here I have the trim line, okay? And after import. So now you have in the historical window all the tools that I have in my template or in other file. Imagine that you want to import from a patient folder. In the trim lines, you have already the trim line in case you want to import in Cube to design for the 3D printing. For example, now you can see that all the areas are in the good place. In case you want to import in other shape with differences according the height, it's possible that some areas are higher or lower, so you need to edit and move up and down. For example, imagine that this one you don't want to have here, so you can move where you want, but you save time. Okay, imagine that everything is okay, so you can save like a new library form. So this is template BK. Okay, now we want to do a sample with a TLSO. So with the TLSO, let me close the software, open the Captivia file of the scan, create a new patient here, close, go to the patient folder, you need to extract the scan, okay, and now create a form. Okay, now in this case I need to align more. For example, something like this, I think is okay. In this case, I didn't take care about the arms because I will use the short radius, so the system will use only this part. If I use the large radius, the system will use this is the long radius according the axis. So at the end, the system will fill the space between the arms, so you can get like an angel. But now I want to use the sort I already saved in my computer in the advanced mode. I explained in the webinar when we spoke about the spinal braces, so I think it's not up, no, because he saw say here for any reason I use the large radius, so this is not good. So you can go back, advanced mode, and now click on next 3 windows, 2, 3, and in this one you need to use smallest, so the system will use the internal one. Now is okay. When we get the shape, we need to, in this case, the bottom part we don't need. So I want to cut something like this, the neck, and now it's perfect, and open. So now we need to prepare, we need to prepare, because this is not very good. I want to turn a little bit because I want to cut this arm. So with the basic tools and the carve saw, I want to cut from here, and double click outside to finish. If you don't like, you have the possibility, remember, to move and put where you want. So I want to cut here. Okay, if you have problems like this because you don't put the mouse exactly in the line, turn a little bit and click on the plane. Okay, now I want to restart. Let me wait a minute. I want to leave something like this. Okay, and I want to use the curve, so I click in the wrong place. So my idea was to use the symmetry to copy this line in the other side, but anyway, I want to do something like this, turn a little bit and cut inside. Okay, so now I want to start, for example, with the rasp in the bottom part. I want to add material. For example, here I have a big hole here. I want to add material here. At the same time I want to add material here. Okay, I want to add material in the top part. Okay, and now, for example, I want to use the plane. I want to limit amplitude at I don't know, 5 millimeters, for example. Okay, I want to use this small one to remove material here, and in the back part also we have this bra. Probably can increase 7 millimeters to remove it. Now I want to use a new one because I want to apply the normal over all parts, so it's better to use a new one. Okay, so now I want to increase and I want to start to smooth everything. I want to use the vertical here. Okay, and here. In this case, at the end, we are working to get a good shape, so it's not really important if you remove more material in one part. Okay, I think everything is okay. Let me save it and check. Now I need to smooth more. For example, with this one I want to do something like this, for example here and here. Okay, imagine that is perfect. Okay, so now I want to apply the complete smoothing, for example, to help a little bit, and now you can see that the shape is not symmetrical. So with the balance and apply the 100%, you have a very good shape. So now I want to convert this shape in a new Rodin 4D shape without the steps I have already here, because I want to start from zero. So in this case, you need to use this functionality. If you haven't here, go to the advanced tools and use the shape rebuilding. This is a TLSO. We don't need to modify nothing because it's the same alignment I did before. Next, check the bottom part and the top part is open, it's okay. Imagine that you want to cut a little bit more the lower part, so you can use it. Okay, and after finish. And now you have already your shape. And after this is okay. In a real case, of course, in a real case, it should be great to leave, for example, this part better. So probably with the, but I forgot to, I could do the same. But anyway, this is the process, okay? And after this, you decide which rectification you want to apply, and after save like a new RXP, like before. Okay, now I want to show you how you can convert one AFO in a library form. In this case, in my library, I have this is the long axis. Okay, and now in the insert, I click on file. Okay, and I look in my computer on the desktop my KFO, my AFO. Okay, imagine that this is one positive shape that you like, you scan, and you import the STL inside. Open. Now, let me click here. Okay. I want to leave approximately here. I want to apply a little bit of transparency. Now I need to reduce the radius because it's a very big. I don't like it. This is more or less okay. I don't want to see these lines, so I go to display and click on form. Okay. So now I think it's okay. I want to use the bend tool because I need to bend the axis to put approximately here. So with the bend tool, two levels, bottom part, anterior, posterior, and I put one level here and the other one here. And after I want to move, be careful with the angle you apply and the position of the levels, because if there is a collision according the radius into the shape, you will get a bad shape. After I will try to do strange things to show you the problems we can do. Okay, now I want to use a new bend tool, two levels, 1 and 2, anterior, posterior, bottom part, and I want to leave something like this. This level I want to move, for example, like this, and probably I need to reduce. Okay, let me check if everything is okay. I think it's okay. Perfect. Now I want to see the front view, and in this case it's not really important, but if you want to leave in the midline, you should in my FO templates this part is completely straight, but if you want to bend like this, you can put here mediolateral top part. I want to leave something like this. Okay, and at the end I will repeat again to bend a little bit in the top part, for example. Again, this is not important. Something like this. And after, if you want to see from the top and you want to move a little bit to the medial, in this case I prefer to start with the lateral view, to put two levels approximately on the ankle, 1 and 2, and after is the bottom part. In this case is mediolateral. You can turn like this. Okay, so now everything is okay. We want to convert this scan in a new Rodin 4D form with the same axis I prepare. So in the advanced tools, you have this functionality. I have ready in my custom bar to save time. If not, click on the advanced tool and current axis shape rebuilding. At this moment, it's important when we speak about AFOs and KFOs, it's important to check the shape building. This is the distance between the sections. 1 millimeter is okay, and I feel is the one you need to use, because if you increase this value, for example for TLSO, the distance is 4 millimeters. So you can see that, for example, if you use 4 millimeters, you have one section, and 4 millimeters lower another one, another one. But in this part you will have a problems, because you can see with this flexion we apply to the axis, the distance between the sections here will be bigger. So at the end you cannot reproduce this curve contour. So this is the reason that I use 1 millimeter. Okay. After this, click on next. This is not important for you. Now the software takes time, because this scan is too heavy. Normally you don't need to have a scan like this. Okay, next. You can see that now at the beginning, when you use this functionality, remember that you was using an axis, this one, and the scan. By the system automatically, by default, deactivate the axis. So at the end, you will get the blue surface. Inside, you will have the original axis, but you cannot see. So we have our shape. Now I want to control the top part. So if I reduce 2 sections and this one I want to leave open, okay, I'm finished. So now you can see our scan, we already convert in a new Rodin form, Rodin 4D form. And if you click here, you will see the axis is exactly the copy of the one we prepared to get it. Okay, after this is the same like AKBK. It's important to think about what do you want to save in your template. Of course, the first step is to put all the levels. In my opinion, at least you should have at the toe metatarsal, diagonal, supramalleolar, calf, and top. And after this, you can, of course, for me it's mandatory to save all the steps to rectify this type of devices. And after this, click here and save like a new RXP. Okay, so now I want to save like template AFO webinar. Okay, so now I want to show you how you can create one CAFO template. So I go to my library and I will open again the same axis. You can see that in my template, in my library, I have many axes, because if you need to bend in different steps, different directions, something like this, and you feel that you will repeat in the future, so it's much better when you modify everything to save like a new template, curve axis for CAFO, for HCAFO, for everything, no? But in a real case, probably you have only one, so I want to show you. Probably you have this one, this is the axis, but I prepare one is longer. I will explain at the end of the webinar how you can create one simple axis. This is longer, is 1 meter. So I want to open, okay, and now I want to insert one. Of course, you can use it to you can use some shapes that you have in Neo. You can apply modification and you can create like a new template or library form. But again, you can scan a very good CAFO you have in your facility, insert and merge. Now I want to do something like this. Imagine that I scan a very good shape, and now I want to take the CAFO, okay, and this is the lateral view. I want to start to move to the top, okay. I want to reduce with the radius, okay, save it, and now I want to start to bend like this, for example. This part is not important if you live completely straight, but if you want to bend a little bit to put approximately here, and after bend to go back, and after the ankle, you can do it. The most important thing is to understand that in AFOS and KFOS, you will have levels, and all the levels, you can imagine, you have here the reference of the blue line. All the levels are perpendicular to the axis. So if you bend a lot, probably this line is not parallel to the floor. So in this case, you need to understand, to check, to take the same measurements on the patient. I will explain to you, and after you will understand. For example, now I want to bend the top part mediolateral, and imagine that you want to start to bend from here. Okay, and now I want to lift something like this. Okay, let me move this one higher. Okay, go back, okay. For example, no, I want to, let me, okay. Where is the, I cannot see very good, but anyway, I want to click here. I want to look, I have here the level. This one I want to look like this. Something like this. Okay. Imagine that now here is more or less okay. We don't need to bend more. So now I want to bend a little bit in the lower part. So with this one, I want to put, for example, something like this, and like this. Bottom part, anterior, posterior, leave, for example, like this. And after, for example, you can start here and here. Posterior bottom part, you can do something like this, and after in the lower part, and you bend to 2 levels, bottom, anterior, posterior, one here. I don't know if I put it or not. Yes, I put it. You have one level here and the other one here, but this one should be here. And after you want to bend, you need to bend, not more. I think it's okay. And after a new one for the 2, let me click here and click here, and bottom part, anterior, posterior, and let me probably this one, this level I can move higher. Okay, and at the end, the last one in this view, 2 levels, bottom, anterior, posterior, 1 and 2, and something like this. Okay, from the front view, you can do, if you want, the same. But again, for AFOS and KFOS, I didn't take care about it. But anyway, if you want to bend like this, you can do it. For example, 2 levels here and here, mediolateral bottom part, for example, something like this, two levels. Okay, let me 1 and 2. I want to put here, and the other one approximately here. Yes, mediolateral bottom part, to do something like this. Okay, save it. And now I want to use bend to two levels, for example here and here, bottom part mediolateral, sorry. And now I want to leave something like this. Okay, if at the end you want to bend more like this, you need to put two levels in the back part, and you can this is not basic tools. The bend to two levels, 1 and 2. I don't know if I put yes 2. Bottom part, anterior posterior, no, mediolateral, sorry. I want to see from the top, and I want to bend a little bit. Okay, so now it's important to check everything, and now I want to show you the differences according the axis. For example, here is more or less parallel to the floor. We will see, for example, here, if you decide to bend like this, and imagine that in your measurement protocol you define one level exactly here. It's not the same if you take the measurement on your patient with this inclination, or if you take parallel to the floor. There is not a big difference, but sometimes if you bend a lot, you will have differences, so you need to think about it. Normally on the knee I like to leave straight. Look, for example, here. Imagine that if you in your measurement protocol you have some inclination here, so you need to specify. This is one of the reasons that I prefer to leave straight, but I want to explain you many possibilities, I think. Okay, so everything is okay. From this view is also the same. For example, here, imagine that you put one level here. You can see that when you modify with the measurement tools, the circumference at this level, this circumference is not the same like this. This one, parallel to the floor, should be smaller than this one. So you need to check everything and speak with your colleagues who will take measurements on the patient to use the same information. If not, probably you have problems. And this is one of the most problems, the common problems that many people have when they use a CAD/CAM system. Okay, so now I need to convert like a new RXP. Remember, if you have not this tool here, go to Advanced Tools and Current Axis Shape Rebuilding. 1 millimeter is okay. Next. This is the same problem with the A4. This STL file is too heavy, because it's not true that I went to my workshop to scan a positive shape. I import from Neo in Cube, and I start to modify and doing nice things that in Neo is not possible. So this is like I try to explain to many people, that for me the combination of Neo and Cube softwares is amazing, because you can see here we have a bottom to import in Cube, so you can quick take from Neo, go to Cube, do some things, import again in Neo, and you can do very many things. Oh, I click when the computer was thinking, so I don't know. We will see. We have the shape. Now I want to cut the top part. Okay. And the front part of the toe. Oh. Okay, I think it's okay, perfect. So now you click here and you have very good shape ready to make all type of CAFOs. Okay, in case you want to use a measurement protocol, you have everything already rectified, with the toe box to have more space to cut in the medial and lateral and the toe and everything. And after, of course, you need to save like a template CAFO webinar. Okay. So now to finish, I want to show you how you can create an HCAFO. So in this case, I will use a shape. I will take in Rodin for a torso, and I will combine with this CAFO. Okay, so now I want to close it. So for HCAFO, I go to my library, select the long axis. Okay, and now I want to insert. I was thinking, for example, in my library in UK, you have a body jacket. This one, in these cases, I want to select a shape with a good waist. And the trojante also is important because you need to think that the CAFO I want to merge has the upper part. So let me, for example, this one, I think this is big inclination here, so probably this one is much better. Okay, front view. I want to move to the top. Okay, and now let me reduce the radius again. I don't know why I save at the beginning this axis with the radius reducing, because every time I need to repeat, so you can prepare. Okay, now on the insert, I want to move on the right, because I will merge the right CAFO, so I don't want to, if I put the axis in the middle and after I bend to go to the AFO, I will have problems in this area according the collision of the radius inside. So for example, I think something like this. I will have problems here, but it's not important for us. So let me okay, I want to leave something like this. Bien. Now file. I want to oh, I was thinking I want to insert the CAFO, this one. Okay. And now I want to, for example, I forgot to put some reference or mark. It's important to align and put in the good place to identify. For example, you can identify very fast here the throw hunter, and here probably is approximately at this level. So I will move the KFO and I will leave approximately something like this, okay? And after I want to move more media. I think this is great. This is great. Probably you decide to turn a little bit, but anyway, this is not important now. So as you can imagine, I have two inserts. So I will merge the first one, and after I will merge the other one. Imagine if I merge like this. If I merge like this, when I merge the torso, I have no problems, but when I merge the KFO, yes, I will have a big problem, because the system at this area will add this material that we don't need, and also with this one. So in this case, I prefer to import this KFO quick in Cube, because in Cube I can cut and after import and apply the we are in 7. This is the good position to remember for after. And now I want to separate a little bit to save time, and after I click here, so the system will open automatically Cube, finish. Okay, and now in the tools with the modification, I want to remove this, I want to activate this one and invert the others, so I will remove, and after I want to save it, and after in the creation I have the possibility to draw a curve. So I want to, okay, for example, I want to come from here, from here, from here, from here, and after we don't need a lot of space, let me come from here and after this with this I want to remove this one. Probably this I need to reduce a lot, because we don't need a lot of space. Something like this, for example, is okay. And after I want to, let me click on the front view. Okay, good. Sometimes you want to go very fast and you have some problems. I have problems because when I import, I decide I didn't align, so takes more time, but anyway, I think it's more or less okay. Okay, perfect. So I want to cut. This is the part we don't need. So this is our KFO, ready to export to STL and import in Neo. So I go here, export as, I don't know, for example, here I want to rename like a Rafa KFO. Okay. I don't need Cube. And in Neo, this one I don't need right now. let me delete. Okay, and after insert the new one, standard Rafa Keifo, this one. Okay, and now let me put here like a reference the blue line. Wait a minute. Okay, I think it's okay. Imagine that yes, this is the good position for the throw hunter. Okay, in the insert I want to move something like this. Okay, in case for any reason you want to bend a little bit, you can bend. This is up to you. So let me check if in the front view it's okay. I think we need to move more posterior, something like this. Let me check from the front view. I think no, we need to move more like this. Okay, and after from this view probably we need to move more posterior. I think it's pretty cool. Okay, so let me yes, I think so. I think it's perfect. If I click here, for example, we can leave. I am looking that when I prepare the A4 it's a little bit in a keynote, so anyway, in a real case we can do it something like this. Okay, so now I have ready both shapes, and now I want to deactivate the we can start to do, because imagine, no, because now I want to bend the axis according to the shapes. If you want to save, it's better to bend first, export like a new RXP, and after merge. So I will do something like this. Now in this view I want to bend the shape 2 levels, 1 and 2, mediolateral bottom part, something like this. I want to select the first one. Okay, again 2 new levels, for example one here and the other one here, mediolateral bottom part to move. I don't like it, so this one I want to move something like this. I think it's better. Okay, now at the knee, bend two levels, 1 and 2, mediolateral bottom part, mediolateral. Okay, something like this. For example, a new 1, 2 levels, bottom, mediolateral, and 1 and 2 to leave approximately here. Okay, from the lateral view is more or less okay. If you want to bend according the knee, this is up to you. I told you before that for me it's better to leave straight, but anyway, if you want to bend a little bit, you put one level here, the other one here, anterior posterior, and go back. And at the same time this 1, 2 levels, 1 level and 2 levels, anterior posterior bottom part in the other side. Okay, I want to check if there is collision or not. I think it's perfect. I need to bend 2 times more in the bottom part, anterior posterior, probably one here and the other one here, and I want to do something like this. Probably this one I want to leave approximately like this. Sorry, I want to increase for you to see better. Two new levels, 1 and 2, anterior posterior bottom part. Okay, and now let me think. Okay, the front view. The front view is perfect. I want to explain you again the possibilities about the circumference. At the knee joint, I try to leave parallel to the floor, but it's important to check everything. Okay, this one, you can see that there is some inclination. If you check from the back view here, the knee joint is more or less parallel. It's a few difference. But for example, this one, if you want to take these measurements, you cannot take straight like this on the patient, because your level will be with this inclination. So this is really important to understand and explain to the people that you have on the hospitals taking measurements. At the end, if you want to bend a little bit to put more medial, the last two here, 1 and 2, two levels. I need to first to click on 2 levels and after put the levels. Bottom part, mediolateral, and after click here and do something like this. Okay, so I spent several, I don't know, 10 steps to modify my shape. So before to merge, I want to keep this one in case I want to reuse in the future. So I don't want to save with this, so I click here and I save like a long axis for K4. Okay, so I have a new one. Okay, and now yes, I want to take it. This one I want to merge with the merging tool in only one click, very fast. Perfect, I don't need it. Save it. Now I go to the insert. This one I want to check that everything is okay. I think yes, it's really nice. So merging tool, let me apply. Okay, you can see much better. Merging tool, here it's perfect. You can see that we reproduce exactly, and in the anterior part you can see that we resolve this material that the K4 template has, like this. So now it's important to increase a lot. Okay, I want to add material in this part because I would like to have the reference of the trim lines. So with the rasp only add, I want to add material like this. For example, here you can, this is not important for me because I hope I have the reference, but anyway, you can, if you want, you can add material to leave. Probably if I increase more, I am adding more material. Okay. I think it's perfect. I think it's perfect. This part is not really important. In a real case, when I cut the K4, should be great also to cut the this part of the brace, because at the end we don't need, you know. But anyway, this is a sample. I want to add like this. Okay, perfect. And now I want to use a new one because probably I can smooth. I will try with the eraser because it's the normal is sometimes is very strong, and I want to smooth, very soft, very soft. Okay, and something like this. No, the last step I don't like because I add material here, so I want to undo one step. Okay, perfect. So let me check. I think it's pretty cool. So now I want to apply a complete smoothing, and everything is okay. Everything is okay. Okay, for example, I don't know if now I can. No, it's okay. We don't need to. Okay, so now I want to convert in a new Rodin 40 form without these steps. So how? With the current axis shape rebuilding. Advanced tools, current axis shape rebuilding. Is 1 millimeter, is okay. We can check that everything is okay. And next. In this case, I want to remove the top part because for one HK4 we don't need. And or you can keep like this, because you know sometimes you need to make K4s with a long brace, and you have time to cut when you need. This is the same of the K4 template that I prepare. I decide to take one leg and merge with one AK socket in case I want to make a K4 with ischion containment or something like this. If you need, you can use it. If not, at the end you can cut before to send to the robot. Okay, next. And now we will have the HK4 ready to save. Okay, this is our template. Now I want to open the top part. Probably with the control I can go faster. If you decide to cut more, of course, if I am moving my scroll of my mouse, but if you click on control, you can move faster. Okay, so you decide if you want to leave like this or what. And after, yes, the bottom part I want to cut. Let me move a lot. I don't know if let me probably in 100 is okay. I want to reduce more. 1, 2 and 3. Perfect. Okay, so save, finish, and you can save now like HK4, and tomorrow you can open again and you can add more things. So now I want to click here to save like a template. K4. And that's all. And now to finish, I want to show you how you can create and simple axis. So to create a simple axis, you can use our inserts. You have in your library, at the beginning you have two folders in French and English, and after you have also one axis. It's the same like I was using in AFO and KFO, but shorter. But imagine to create one trick to create a very fast an axis. You can open one shape, it's the same. For example, I don't know, this one, no, this one, no. This is a curve axis. For example, anyway, one body jacket. This one, no, this is half, okay. This one, and after you go to inserts and you use a cylinder. It's important to leave the cylinder to align to the axis we have in the torso, okay? After this, you can increase till 1000, for example, okay? And that's all. And after you merge, at the end you will merge from here to here. I will lose this part anyway. But you click here and you merge, and you have already, I don't need the, I will lose the top part because it was outside of the original shape, and the lower part, but you have a new axis. So when you have a new axis, you save like axis straight or something like this. For example, if you click here and you put axis webinar, and you save, now if you close it and you go to your library, you can see that I already create the axis webinar, this one, and that's all. So that's all for today. I hope now from this moment you can start to create your templates. I share with you 6 samples. I think it's enough. So that's all. Thank you very much to be there. Have a good day, and I hope to see you next week to see the upper prosthetics in Neo and Cube softwares. Take care. Bye bye.